Okay, good morning everyone. In the previous class, we discussed about the Epsilon NFA. So now in this particular class, we will be discussing about the conversion of Epsilon NFA to its equivalent DFA. Right? Okay. So in the previous classes, we have already discussed how to convert your NFA to your DFA. Here also we follow the same procedure by using substitute construction method or lazy evaluation method. You can do perform any operations. So here we'll go with the simpler technique of lazy evaluation. But the thing is, you are going to convert epsilon NFA to its equivalent DFA. So epsilon NFA is to convert this epsilon NFA, you need to go with the E-closure concept. The concept of E-closure. E-closure. So what is this E-closure? What is this E-closure? E-closure is a concept where from any state to any state, if there exists a transition upon your epsilon, then that particular state is called has some transition. That is E-closure. E-closure of that particular state will be considered. So E-closure of, for example, I take 1, 2. So E-closure of 1 is equal to state Q 2. Because the state 1 has a transition to state 2 upon its epsilon. That is called E-closure. So anything or any state transits from one state to another upon epsilon, then it has the E-closure for that particular state. So E-closure now identify model. Conversion alli ನನಗೆ ಈ concept ತುಂಬಾನೇ important. So for this, we'll begin with our problem. So rest other things are very similar to your conversion of NFA to its equivalent DFA. In the step 1, you are going to identify what? Beginning state, right? The start state. So here, since we are using it as a epsilon NFA, we are going to apply the start state upon its E-closure. So E-closure, though, identify model. So let's begin with the example directly. So let us have one problem that is being converted from epsilon NFA to its equivalent DFA. Let me have, I have a state called Q0, Q1, Q2. 3 states, and here I have a symbol A, and this is epsilon. Next I have a B, this is epsilon. Next I got my C. Right? Let us consider this example. Since the transitions from one state to another state happens upon your epsilon, it is called as epsilon NFA. And there are not necessarily all the transition for all alphabets. It is a complete NFA. For this, I need to convert its epsilon NFA to its equivalent DFA. To convert this DFA, first step, what we need to do is, first step, identify the start state. The start state of your first step, start state of DFA, equivalent DFA is equal to the E-closure of start state of epsilon NFA. Start state of epsilon NFA. Here the start state is Here the start state of DFA is equal to E closure of start state of epsilon in FA. So epsilon in FA start state as a Q naught, right? And the resulting states will be Q naught from Q naught wherever all the states are reachable upon your epsilon. So upon epsilon Q naught is reachable. Yes, Q naught is reachable. So epsilon ಅಂತ ಬಂದ್ರೆ ಅಲ್ಲೇ ಇರುತ್ತೆ. Next upon epsilon Q1 is reachable. Yes, Q1 is reachable. Upon epsilon and epsilon Q0 Q2 is also reachable. Yes, Q2 is reachable. This is my start state of your DFA. So start state na yes DFA. Start state of a DFA or equivalent DFA is this particular. Right, this is the start state. And if you have a number of states for equivalent NFA, you got Q0, Q1 and Q2, right? These are the only three states I am having. Here I got my new state. This is a new state identified for your epsilon, DF, equivalent DFA. I consider it as a new state. Since I found it new state, I am going to move on to the transition of all the alphabets upon these particular Q. So, so before going to that, second step is to identify alphabets. So, alphabets of your DFA will be alphabets of your NFA. So, this will be what alphabet set will be A, B, C, and epsilon. Since I am going to convert it into a DFA, I am not going to use my epsilon here. I will have only the alphabets A, B, and C. Right? Next, final state at the end of the Okay, I forgot to draw your final state. This is your final state. Clear with this? Now we move on to